Good morning, everybody. Welcome to our Subspace integration sync. Today, we're going to talk about our new execution layer, domains, cross-chain messaging, cross-domain messaging, and our progress towards all those things. This is going to be the last weekly integration sync we're going to do. We're going to start doing this bi-weekly. So this recordings will come out every 2 weeks. Most of the activity will be on GitHub outside of that, but we'll be reviewing the highlights every 2 weeks. Okay, so to start off, Lu Cheng, if you'd like to give us an update on what you've been working on.
Yeah, of course. Let me share my screen. Yeah, you should be able to see my screen. So last week, I was primarily working on Palette Domain Registry, which we have 2 PRs merged. So the first one is to mainly prepare the template in which I basically implemented several interfaces for create a domain, register or deregister the domain operator, and update the domain stake if you are already a domain operator. Those interfaces are implemented in this PR. There are some details needs to be kind of resolved later or clarified later. One is, I think, is for this bundle frequency in the domain config. I believe we would better rename it to the bundle slot probability, same with the slot probability on the system domain, so that we can have a unified API for the bundle election. The another thing, small open question, I think is, when you deregister a domain operator, maybe it's also nice to have a constraint on the minimum domain operators. We have this constraint on the system domain for the entire exactor set. So, Gemma, do you have any ideas?
Yeah, let's push that to after the updates, Lu Cheng. These are great points, though.
Yeah, sure. So the next PR is primarily to rotating the domain operator authorities whenever the exactor set is updated on each new epoch. So we are using a treat to hook into the Palette domain registry, a Palette exactor registry, which is I believe it's new epoch. Yes. So when we have this treat, this hook in the Palette exactor registry, whenever we the domain authorities are updated on new epoch, we also rotate the domain operators for all the domains. There's also another PR, which is to unify the domain ID type. It's really helpful for the future development on the domains. It's a pretty lower concept. So that's one thing we probably it's also maybe discussed later. So just one thing, the ranger for different types of the domains. The goal is to determine the type of this domain by using the domain ID, by only using the domain ID. So So if this like domain 80 is like smaller than 100, we can consider it's like a system domain. It's like smaller than 1000, we can consider it's a codomain. Otherwise, it's an open domain. So something like this. Yeah, that's the main progress from last week. Another thing is that I did basically a lot of preparation for the codomain nodes implementation. That's the focus of this week. So the main point of this issue is to like have this initial codomain nodes support. The main points are this first thing is to like support you run a codomain nodes from the command line. So yeah, we also had a document like described like how will we like run a codomain node from the command line, and another suggested a better idea we can. So that's probably the final look when you run a codomain node from the command line. We specify the arguments for running the codomain node in the end after extra like dash flag. The another like important thing is to like basically migrate the existing executor to kind of the system executor, like, and the co-executor, which means like an executor like running on the system domain and an executor and running on the codomain. So before we come to this point, there are some refactorings need to be done first. So those two refactorings is basically to make the current like the current executor or the current like domains to be domain aware. Currently, we have this assumption that there's only one domain, which is the system domain, and we need to like migrate this framework to support like multiple kinds of domains, including the system domain and open domain, and at the future, like system domain, codomain, and at the future open domain. Yeah. So the first part of this series has been opened, which is to make the current bundle producer like domain aware. So put it simply, is to add this like domain ID to the bundle producer and make the previously the bundle election like is specific to the system domain, but now like we are going to support multiple like bundle elections, like for the system domain, and also probably like potentially also for codomain. So that's multiple bundle election challenging solving at the same time. We need to make this like domain specific. So the whole idea is to So when the algorithm for the bundle election is basically the same. The different thing for between the system domain and the codomain is the parameter fit into this like bundle election solver, and that is like basically this for the system domain, it's the entire like executor set or the entire executor authorities. For codomain, it's from the entire domain operator set or the like domain operator authorities. and their like slot probability, but the structure is the same. Yeah, that's all the things so far. Yeah. Any comments, questions?
Yeah, it makes sense to change it to bundle probability. We need to change the spec as well to reflect that.
Yeah. Actually, I already updated that field in the spec.
Great. Okay. Whenever you make updates to the spec, can you just notify me so I can just go in and take a look at them? I know I get like,
sure. Yeah.
I know that there's like automatic notifications in Notion for updates, but I'm subscribed to like 50 documents, so I just get a constant stream of Notion notifications that I can't keep up with. But just like ping me in Slack if there's going to be a change to the spec, just so I can take a look at that. Okay, cool. Thank you. For the domain ID types, this like namespacing of ranges of domain IDs, I think that we're over optimizing right now, honestly. This is going to change a lot, and I don't want to try to hard code this into the system right now. I don't think it's strictly necessary to get this up and running and get it tested, which is the core concern. So I think that this is more like we need to kind of document this and put it in the backlog as maybe a next iteration feature. Right now, we can just assume that we have one system domain, which is domain 1 or domain 0, and then some number of core domains. We don't need to go ahead and like have the whole range scheme built for open domains just yet. That's kind of the idea here, is to proof out some of these ideas before we have the whole scheme defined.
Yeah. Just for the future proof. Currently, all the work are done in like under the assumption that there's only one system domain. Yeah.
Okay. And then for the command line, that's fine the way that you and Nizar are doing it. I'm not too concerned, honestly, about developer friendliness or user friendliness for this. The Substrate node experience is already not super user friendly for non-technical people. So that's fine as long as we know how it works and we document it in our READMEs so that our team can start it up. This is kind of what the SDK and the unified CLI is designed to handle. So as long as we can figure out what that Subspace SDK or Subspace CLI domain node args look like, then that's the thing I'm more concerned about from a usability point of view.
Yeah, makes sense.
Okay. And then the deregistering of the domain operator, I didn't quite understand that one. You were saying there was you wanted to put a constraint like on how many could be deregistered or how many had to be registered at one time?
Like basically like if it's allowed to deregister all the operators.
Okay. Yeah, that's another, like, given that this is kind of a trusted setup right now, like with permissioned operators, I think that's more like for open execution or open, like community run executor nodes, which is going to be like the next iteration here. So I think, again, that's maybe for the next iteration.
Sure.
Okay. Did that answer all your open questions, Liqiang?
Yeah.
Okay, great.
Yes.
All right. Any other questions or comments from the group on Liqiang's work? Okay, great. All right, thanks, Liqiang. Okay, Ved, you're up next.
Cool. Give me a second. 1 second. Yeah. Hey everyone. Last week, the majority of the focus was to finish up the relayer portion of it that actually relays messages from the system domain, because we have most of the work done on it on the client side. So that's why we started out with sending messages from the system domain itself. This PR essentially handles that and also makes some changes. Uh, make some changes to the relayer like client, such that it's much more easier to extend this to relay core commit messages that is going to be coming next. Um, Maybe let me quickly take you through the main changes, and that would be easier. The main changes that are there are in the client relayer under the worker. The what basically we just expose this particular function that is just relaying a system domain message that just as a blocking task that runs as a co-process with other executor and other processes that are running in the node itself. What this basically do is that wait for a confirmation block and then starts to take all the messages that are present as part of that confirm block and then relay the message to the codomain from the system domain. Um, and we also automatically handle the proof accordingly, because a message coming from a system domain is different from a message coming from a codomain, because this domain itself is a trusted third party, so it doesn't need to have any secondary proof, unlike a codomain, which is not which needs to use system domain as a trusted third party, where it needs to generate two proofs. One is for the message itself, and the other one is that the state root is actually present on the trusted third party, that is system domain. So this particular PR handles just generating the message proof, because we are sending a message from the system domain. So it should automatically be verified on the codomains, because of the domain tracker that we have introduced here. The domain tracker, as we've discussed previously, what it basically does is it exists on the domains that actually tracks all the confirmed system domain state roots passed by the client through the inherent data before the block is about to be imported into using the runtime. So what it basically does is for every block that we build, we inject the last confirmed system domain root, and then this particular palette keep a bound of L state roots that are always bounded to L state roots. So what happens is a new one comes in and we push out the oldest state root that are there, so that we keep the bound. And these bound of state roots are used by the codomains using the system domain tracker implementation to verify the storage proofs provided by the relayer. So this should ideally work for both system domains and codomain, but we added that in this PR so that the next PR is much more easier to comprehend in terms of the changes coming in. That's pretty much it to this PR. Let me take you through the next PR that actually does codomain relaying. Okay, so this PR is not completed. This is the main focus for this week for me because the new changes that we require to actually relay core messages are just introduced by Liu Sheng on in the last 2 or 3 PRs that he just spoke about. So I started pulling on those changes and started working on making actually so the main changes that goes into this one is actually relaying the message from the codomain. So that means when relaying a message from the codomain, we would have to create a secondary storage proof from the trusted third party, that is system domain. So we are making this PR essentially brings in those changes. Let me quickly go take you to the main change. I think, yeah. So the main change here that we've added is collecting the codomain state roots. Right now, the domain registry, it does have a basic implementation, but it doesn't do fraud proof verification right now. It doesn't do any bundle verification as such. It's just like Liu Zhang mentioned, it's just a template. So ideally, once that particular domain registry is filled up, once we start confirming as a codomain state root, that gets added into this particular called by the system domain runtime, and then this is a particular storage call that we use by the relayers to actually verify the state root of the codomain on the system domain. Does that make sense? So again, the worker is not done yet. I'm still in the process of writing the worker. So this PR might not make complete sense like the previous one because some of the changes are not yet introduced, but that is the main focus for this PR. I'm happy to answer any questions or any concerns.
Okay, so no blockers or open questions right now then?
No blockers. So the main so the main focus for now is to get that worker done for the codomains. Once that is done, the further changes that we need to do is routing actual transactions that we've discussed last week between the domains as such using the GlobalNet. So Lusheng is mentioned that he's working on the client changes this week, so I'm not going to touch that. In the meantime, I'm going to finish up the runtime changes now. And then once the client changes are in, I can actually pull in those changes in a different PR. That might make that actually helps us to much closer to the testing of the layer. Yes, ideally, hopefully, end of this week. Again, depending on how we are moving, but I'll keep you guys posted on any blockers.
Okay, great. Any other questions for Vet? Nope. Okay. Thank you, Vet. All right, Parth, you're up next.
Yeah, so from my side, I have deep dived into Celestia. So to be specific, yeah, to be specific, I dived into the code base, basically Celestia node and Celestia core. Celestia core is just Tendermint based Celestia data availability, like, so basically core implementation of its consensus that does transaction ordering, while the node contains the bridge node implementation as well as the light node. Bridge node adds some more data to the header, makes it extended and makes it easier for light client to basically have data availability samples. Went through the proofs, the light client EDR as well. That their light client is really similar to Tendermint light client, but they are using sequential verification versus skipping. Okay, this term might not make sense if you are not familiar, but the general idea is that in case of skipping verification, there is a trust assumption for every like for every time t of number of blocks, and so basically you don't need to sample every block in the light client, while the sequencing implies that you verify each and every block as it comes in. But since Celestia does not require honest majority assumption, at least for data availability, it needs sequential blocks. Apart from Celestia, I've been looking into L2 protocols. To be very specific, I looked into Hope, router protocol, and IGN layer. All three, I have written up about it. Regarding Celestia, I have done my research, but I've been just trying to uh, write a more comprehensive section compared to other protocols. That is what I'm doing at the moment. Apart from that, I've been looking into Ved and Lu Cheng's PRs, uh, and in general also looking at the code base just to prepare a mental model. There are recent changes that I will need to take into account. Um, Apart from that, yeah, that's what my update for the last week.
All right, thanks, Parth. Any questions from the group? All right, I'll give you some more feedback on that later, Parth. All right. Jeremy, any updates from your side or anything you wanted to cover today?
Nope. This is my first time at this call, so just observing and trying to piece together the things we talked about last week with what everybody's working on.
Great. All right. Okay. Well, thank you everybody for the updates. Thank you everybody for watching. And we will be back in a couple weeks with some more updates and hopefully be able to show some of the stuff working on our XNet. All right. Well, thanks everybody. See you again soon.